Today, this is the lecture 24. Let's continue to talk about the remote eventer. Last time we showed this code. We show how to implement the root sync multicaster. This is a kernel code to establish multicasting. You can see there are a lot of the most important one is we need to construct a tree. We need to perform some fault tolerance, solve some fault tolerance problems. So there are a lot of details. All the multicasting details are implemented in such a cluster in this cluster. If the root need to broadcast anycast, unicast data to its children, then this cluster perform most of the behaviors. So, however, according to the introduction, you can see that the kernel, one of the most important API for such class is a synchronous remote eventer. We also need to know what is a remote renderer point is. We also need to know how to construct a tree. We also need to pay much attention to the fault tolerance. But all the issues, all the implementations had nothing to do with the low-level distributed system. You just focus on the knowledge description. Such knowledge description can also be regarded as upper level, right? Another type of upper level application. So developers just focus on this. They don't now need to care about a lot of details. So that means remote sync multicaster is supported by DP only plus the distributed knowledge. So that's the conclusion. So next, for this class, we'll continue to talk about remote eventer because we still have one field here. So this field called remote async multicaster eventer. That's different from this one, right? It remote async multicaster eventer. According to this name, you can know that the this field is used to send a notification because it's called eventer, and there is a term here, async. That means the notification is sent in a synchronous manner. Okay, let us open this class. Okay, but different from this one. This is the one we introduced last time. Okay, this is the code we introduced in last class. However, in this one, you can see the code looks simple. However, this code is complex because we need to consider how to construct a tree, how to construct a hierarchical structure, how to send the data. However, how to manage the renderer point. However, for this one, there's no such problem, right? Because you can see here, only the code looks the same, although there are some different field here. So there is a sync pool. I think this is the first time you see such a code, a sync pool. But it's I just mentioned I don't want to explain such code in detail. If you want to look at this code, it's actually it's just a thread pool. It's a thread pool. It provides some concurrence issue. You can use this pool to support asynchronous programming. So that pool actually that pool is the implementation of the such pool is very similar to request dispatcher and the notification dispatcher. I think you still remember these two APIs in DP, right? Request dispatcher and notification dispatcher, very similar to each other, although the name is different. So this pool, you just because I do not need to explain this pool in detail, it contains a lot of code, so we have not so much time, and I think developers must feel boring for that. So I just focus on how to use it. If you want to do something asynchronously, you can use this pool. So it's easy. This is another API I implement, but I don't think, because this API is only related to local programming. It has nothing to do with distributed system programming. So it's not belong to the primitive APIs. I just classify as just like accessory. Looks like a free client pool and the thread pool. You can also see some similar APIs in previous classes. We have some additional APIs that do not belong to primitive API, but they are still useful. So for this case, if we want to do something asynchronously, we can use this pool. Here, there's some parameters here, right? Parameter need to be set up here. And it looks like, according to this parameter, you must have some ideas. You can recall. I'm not sure whether you remember this one. Asynchronous remote eventer. It's actually their underlying system, the underlying implementation are similar, although I use another API. When we implement the asynchronous remote eventer, actually I use almost the same algorithm, asynchronous remote eventer. You can see here the code look almost the same, but I do not want to explain that in detail. So this code, asynchronous pool, is almost the same as this one. Almost the same. And but the difference here is this one is a multicast message. However, this message is simple. It's simple. This message, I explained this message before. And another one is, if, for example, we can start from here. If we want to send this message asynchronously, we can initialize this pool in this way. Initializing for this code is similar to that. Let us take a look at this. You can see the parameter. The parameter almost the same, right? The parameter. So actually the underlying details is almost the same, but I don't want to explain that. Okay, just want to focus on how to program that. If you are interested, you can take a look at the details. Okay, here, but one difference from is here. There is those parameters used to set up the thread pool. However, if this pool, what is behaviors for this thread in such a pool? I have another attribute, the attribute called actor. So if you want this thread in such a pool to do something asynchronously, you need to define an actor. This actor is a behavior for each thread in such a pool. So let us open this one. Okay, when you open this one, you see here, there is a class here, the field. This field, we talk about this code in last class, right? This class is the kernel for perform multicasting. So here, there is the instance here, and but this instance of this class is shared. So when need to initialize it, you need to have in the constructor, the instance is shared by others. So here, let us take a look. This one, right? There is a multicaster. It's a root sync multicaster. It's put here. So this one, for this async removed root async multicaster eventer is shared of root multicaster, right? So if we open it, okay, this multicaster is shared. So all the actor here, all the actor, this one, share the same multicaster. I want to save a lot of resources. So all the compute, because in here, when we perform this one, if we run this code, we need to save, they consume a lot of resources. So we need to save those resources. The primary resource it consumes, what is the primary resource it consumes? I'm not sure whether you understand it or not. It's a client pool, right? Free client pool. That is the major resources. So if all the event actor, all the asynchronous running threads want to need to consume some resources. All the resources is from here, right? This is the primary computing resources that be shared by those, by those actions, right? Those behaviors. So let us open this one. So when you design a system, I think for proficient engineer it's fine, but for some new developers, maybe they do not pay much attention to the computer resources management, but I think that it's very important for you to design a complex system. So okay, that's fine. I think you will learn about that in the later cases. If you program a lot of complex system, you will understand how important. It's very important. That must be one of the most important issues to program high quality system. Okay, then if here this method is blocking method, right? Open it. Let us take a look at this. We talked about this issue before, right? Talk about this method before. So this method is invoked. This method is the broadcast method. So all the clients, all the children of the roots will receive such a notification. So here, however, because this one is this method is a blocking method. However, if we invoke perform, this method is invoked by the. Let us take a look at this. Which one invoked? Yeah, it invoked. Actually, it's invoked by the asynchronous. There is another class using if this method perform is invoked. Actually, this is a thread, right? Async actor is a thread. It's a thread. You can see here is another thread. It's called notification object queue. We have seen another API. It's called notification queue, but this one is notification object queue. Actually, that's same, exactly same. Although the one difference is that this notification here, in our cases, when we in DP distribute primitive, this notification should extend server message. However, for this one, it's no such requirements. So this notification is just an object. Any object can be used. So, this API is not for distributed system. If you want to design a distributed system, you cannot use this one because this is not a message. However, this queue, this thread is also important. Because it's based on the local message, based on the memory, but it's but different from traditional thread. It's a still message passing like system. It's still like a message passing based on thread, not the memory sharing thread. So if you use this thread to perform concurrency management, to perform to design a high performance system, a concurrent system, the thread is changed. It changed from the memory sharing system to message passing based one. So I don't want to talk about exact API in detail. The internal algorithm is almost the same as a notification queue, but this one is not distributed. That's a difference. So this is the thread because it's extend notification object queue, and this thread is managed by asynchronous pull. So the perform this method, you can see here, this method actually is invoked by this thread, and this thread is managed by this pull. So that means this method is executed concurrently or asynchronously. Then this method is converted from blocking method to non-blocking method. So that's through this introduction you can understand why I want to do that. So if this actor, let us take a look at this, how we can use it, right? Here we need to dispose it, right? Here we need to test it whether it's ready or not. You must have seen such code before, right? For the asynchronous eventer, right? The code structure almost the same. The design pattern, if it's a code level design pattern, the code structure is almost the same. First, we need to detect whether it's ready, and then execute it, and then perform. That means this notification is enqueued into this thread pool, and this notification is scheduled by this thread pool to one particular thread, and then the message is broadcast asynchronously. So if you invoke this method is not blocking one, it's called non-blocking method. So then I name it async notify. Okay, we have still some other field. This one is used to the synchronization on the initialization code is all the same, but here the difference is this one. We call this method for this code, the code called children root event actor. This method is invoked. I'm not sure you remember this code or not. For this method, the notification, the multicast notification is sent to the specified children, right? Last time I talked about this one. So here if this, I name it children actor. So the children actor, if the children actor is invoked, then the parameter is a notification, multicast the message, and then we need to specify the children case. Then this notification will send to all of the children, all of the specified children. So this code is similar to each other, right? And okay, next, let us take a look at this one. This one is a multicast message. See such message before. What about this message? We haven't seen that before. You can see here, this is the object. This is the object, not a message that can be transmitted over the network. Because here you can see here, this class does not derive. It's not derived from the class or server message or any other other object that are serializable. There are no serializable classes are derived, are inherit for this one. So this is just a standard object. Is typical object, but this object is a local one. So, however, inside it, there is a message encapsulated. So the message to be sent is this one, right? This is the message to be sent, and this is the children. This is the children. So this one is just a traditional, a typical class. However, this is the message to be sent. This is children that should receive such a message. So this class is just a traditional class. It's not difficult to be understood, right? Okay. So this message is not the message to be sent. It's just a wrapper that encapsulated class that contains all the parameters to initialize the this, to invoke, not initialize, to invoke this method, right? If we want to invoke this method, we need to have the message to be sent. We need to have the children specified, right? So, but all the parameters are contained in such a message. Okay, so you can understand. It's easy to understand. And this one, what about this one? This one called child actor. So if you want to, what does it do? It invoke this method. Let us take a look at this one. This is a unique casting. This is a unique casting. This message should send one child only. Should send to the specified child only. So you must, it's easy for you to understand this message. In such a message, the only two fields. The first one is a message to be sent. Another one should be the child that must receive such a message, right? Let us take a look. Yeah, that's correct. Right? Okay. So when this message is when we need to invoke this actor, we just do this way. No, not this one. This one. Okay. So specify the child to, this is the unicast. And then the message to be saved. Let us take a look at another one. This one, to send the data to nearest to the child that is that is nearest to this k. Okay, that's easy to understand. Okay, what about this one? This method is also a unicast. These three methods aims to perform unicasting in different manner. However, because we use the synchronous pool here, so all the message notifications are sent in a synchronous manner. Okay, so now we finish the, okay, this is RootClient. We finish the explanation of the RootClient, right? So next we need to take a look at the ChildClient. Oh, we have still another one, the root reader. We haven't talked about root reader until now. Let us take a look at this one, root reader. You can see here, root reader is similar to RootClient. Not root eventer, not root eventer. The code is similar to each other. This is root eventer, this is root reader, right? Root reader, according to the name, you can know that root reader is used to send a request. Root eventer is used to multicasting notification, according to this name. But both of them need to share root sync multicaster. And one important issue here, there is because this is a reader. When performing multicasting request, we need to collect responses from all the children. That's different from the multicasting based on notification. So here we need to have the random point. We need to define random point for that. So random point is put here. Random point is initialized. And this one, root sync multicaster, is shared. Both of them shares root. For the remote event, it also share the same thing, because we need to save the computing resources. What is the computing resources? For root sync multicaster is a free client. It's used by sync remote eventer. No new distribute APIs in this case. Okay, so we do not need to care about this one. What about this one? Random point, we have finished that. Okay, let us take a look at this. Root async multicaster reader. Okay. Fortunately, both of these codes have the same structure. They are almost implemented in the same way. The difference is that here, in this case, is a request, but in this case is a message, right? This is the multicast request. This is the multicast message. Multicast message is if you want to send a notification, you use this one, multicast message. If you want to send multicasting request, you need to use this message, multicast request. We have explained such message. So let us take a look at this one first. This one, right? Async pool, this is we just mentioned, explain that. And here, the most important, the actual behavior is here. The action is here. Let us open it. Okay. Read Okay, that this read, we explained this read before, right? If the data is sent to all the children's, all the responses are collected in the random point. If the number reach our expected one, then no wait. The wait will be the waiting will be terminated, and then return the collection, the list. There is a list. All the responses are collected in the list and return, and then the root can get all the responses from the children. So, but however, this one must be running in a running as a blocking method. However, if we want to do something asynchronously, we can invoke this method. Okay, so that's the same thing. What about this? Okay, this is the children's side. We can specify predefine the children's side. That means we need to send this data to all the children's, but we just want to, if the number of children, if this side is reached, the notification can be stopped. This is actually is anycast, one type of anycast. And what about this one? Okay, children. So for this case, this notification, this request should be sent to the specified children. Okay. What about this one? For this one, we need to send the request to specify the children, and if the specified size of children is reached, then the multicasting procedure can be terminated. And what about this one? This is nearest, right? Okay. Nearest case. So here some data case are available. Let us take a look at this data case. This message should be sent, right? This message should be sent, and this is the data case. Oh, I'm sorry, I do not remember this this one. Let me check this one. Nearest case. Okay. I do not remember this code exactly. Okay, that's here. Data case. Let me read this code. Although the program is implemented by me, I almost forget the details. Okay, I see. This message should be each time if the data should be sent. Each time if the message to be sent, we need to select one of the client key that is closed to this data key. I think I'm not sure whether it's very useful or not. Okay, maybe I'm not sure whether I have ever used such case. Okay. Okay, maybe in some cases it's useful, but I'm not sure. Okay, in actually I haven't never used it. It doesn't matter, just leave there. If you maybe this one is this case is a little bit difficult. It's not so useful. It's used seldom. It doesn't matter. When we use it, we can explain that in detail. Okay, now just leave it here. Another one is okay, we can see this one is easy to be understood, right? So we just find one key, find one client that are nearest to this K and send data to it. This is also unicast reading. Unicast reading. Okay. What about this one? Okay, this is unicast, also unicast reading, but the client is selected randomly. Okay, where is the code? Okay, difficult to find the code. Okay, let's open the code. A lot of code is open. Okay, let us take a look at this one. Okay, this is a unicast read. The child K is specified, so we don't need to select randomly, or we don't need to calculate whether this child K is, which one is the nearest to a specified K. We don't need to do that. This is just we just into with one child that is predefined. Okay, so here I think I have already explained all the code on the root side, on the root. So next, let us explain this code. This is the root, right? Let us take a look at this one. ChildClient. What about ChildClient? This is the ChildClient. You can see here, the ChildClient looks simple, much simple, right? You can see this is the RootClient. It contains a lot of methods, right? However, the RootClient contains more methods than the ChildClient. In this way, you can see only 2 methods are available. Or maybe it's three. So methods are available, but actually they are very easy. They are easy. Why? Why is easy? Oh, four methods, sorry. 4 methods. The first one is notify. Another is async notify. The third one is read. This one is the async read. But you must pay much attention to the one important difference. For the RootClient, if notification is sent, no any responses. Because it's notification, no responses is fine. However, if we want to perform reading, multicast reading, then some message responses should be returned, right? Those classes are multicasting based on multicasting reading. However, if so, all this method must have return value. Some message should be returned. However, here, this one used to send a message, right? Send notification. So no return value. That's fine. That's the same as the RootClient. But however, for the ChildClient, if we want to perform reading in a multicast, because this message should be sent to the children's children, right? These children, if the children is still an intermediate node, it must have some children. However, the data, no any responses, no data is returned if the method is invoked. Why? Because all the responses is sent to the root. This is not a good way. You must remember that. This is not a good way to, because in such a system, in such a solution, only one random point is available. Only one random point is available. So all the responses is actually sent to the root. So all the responses are collected by the root rather than by the children. We later will show in another solution. In such a solution, there are multiple renderable points are available. Each, not only the root, but also the intermediate node of the tree have a renderable point. That is a good solution, right? Because each users, because there are multiple renderable points existed, then it saves a lot of it lowers the workload of the root. So each user, each children, after the request is processed, after the response is generated, just send to its parent, its direct parent, rather than sending to the root. So the root is not so busy. But maybe it's slow. It's a little bit slow, right? Because each node, we need to each node in such a hierarchical structure, if it's not a leaf, if such a node is the intermediate node, they have to collect the responses from the children and forward such response to its parents, step by step, until the root is reached. However, this one may be slow, but I say it is a more load balancing approach. Okay, so that's why for this case, only because only one renderable point exists in such a solution. So no any responses, no anything return, even is read. Okay, let us take a look at this code. You can see here, these two codes, these two code, the root think multicaster, this is the child think multicaster, but both of them is similar to each other actually. But the children is a little bit easier. It's easier to be implement, but the overall structure is almost the same, right? Almost the same. This is the only API that are related to distributed is a sync remote eventer. This is also sync remote eventer. Okay, let us read the code. We need to initialize it. Okay, we need to initialize it because this is the children, so no such value is needed. This is the root. Root count is not necessary because it's not root. It just have this parameter. And another difference is that the local IPK is here. For such case, no such parameter. What does it mean? This key is used to identify whether one of the children it's avoid this possibility for the local child to send the data to itself. If no such case, it's possible for the when the root construct a tree, each child must have some IP address of these children. But it's possible one of the IP address is a local node, is a local child. So to avoid this, in my case, when the tree is constructed, it's possible that the current node, current IP address, current children IP address is contained in such a tree. I don't want to explain that in detail. So that key is used to differentiate, to avoid the possibility that the local child send data to itself. Okay, Okay, let us take a look at this one. This code. So all the IP address is contained in this message. So it can get an IP address from this message. This IP address is sent from the children, from its from its root, from the root. You can see from the root. Okay, and then because all the children are available, so it's necessary. It's better for it's possible for its for the local node to construct another tree. Yeah. So here another tree is subtree is constructed. After subtree is constructed, a similar code to this one is used. So in this case, it will send the data to its to its children, following the new the subtree, right? This is the loop. This loop is similar to this one, right? Okay. Then some fault tolerance solution is put here. That is almost the same, right? Okay, so this is for notification. This one is for used to read. Then get all the children from the message, and then construct a tree, and then through this loop, the request is sent to its children. Request sent to the children. Okay. That's all. So a child sync multicaster is a kernel code for the child to perform the multicasting. The same as we have talked before, this code does not contain any third-party APIs to implement this multicasting, right? In short, we have make another conclusion that multicasting, because it's a kernel of the multicasting at the child, right? At the child's node. So all the multicasting API, all the multicasting implementation are based on DP and distributed knowledge only. All we can say in other words, all the for multicasting, at least in this case for multicasting, all the APIs are implemented based on DP and distributed knowledge or upper level application description. So user just using traditional using DP to implement the upper level application. This, for the specific case, the upper level application is multicasting based on tree topology or tree like hierarchical structure. Okay, so let us take a look at the child eventer. I think you can, because we have talked about child root eventer, so this one can be easy to understand, right? That almost the same thing. This is a child sync multicaster. This is a child async multicast eventer. We explained this code before. For this one, okay, that's easy, right? Let us take a look. There's a code that's almost the same as this one. Code is same. Open this one. Code structure is same. But all this code, you don't need to worry about this code. This is underlying code. You just want, when you are in the next classes, immediately I will show how to program with this API to implement some interesting applications. But different from other techniques, I want to spend some time to explain how such new APIs are implemented to prove the new features, the natures of grid free. Okay, for this case, let us take a look at this one. What is it really does? Notification, but I want to, because after this, using this code, the data, the multicasting notification is sent in a synchronous manner. Okay, this code is easy. And what about this one? Okay, this one, we explained this code before. What about this one? This is called Child Asynchronous Multicast Reader. Okay, it's also easy. Let us take a look at this one. Read, right? So this message is sent to its children asynchronously. So RootClient, both RootClient and ChildClient are explained. So I think it's time for us to explain how to use, how we can construct a system application using RootClient and ChildClient. In the next class, I will show you one framework. This framework, based on this framework, we can establish a multicasting based application. I think our system become more complete from now on. Our distributed application become more practical, because I think at present most distributed systems are based on multicasting, because the scale, we need to have a larger scale. So without multicasting, scale cannot be large. Although our system become complicated, more sophisticated, we need to know that those, at least so far, all new APIs are based on distributed primitives. Okay, that's all for today. If you have any questions, just let me know. Okay, see you next time.